paper, cutting hair, whatever, cracking an egg, or chemical changes, burning the paper, cooking the egg, that we have to be able to see if we can come up with a way to identify them. There are some clues. Usually if you have 2 or more of these, you're on can be pretty sure that you have a chemical change. Some of them are a little confusing, so I just want to run through them real quick. Remember, with chemical changes, you've rearranged atoms. You change the composition of the matter. You're not just changing it from liquid to gas by boiling it, you're actually changing what you have. So I can change water into steam, gas, by adding a lot of energy. However, that's just a physical change because I can get all that steam back again as liquid water like we did in distillation. Chemical change, when we run electric current through the water and make oxygen and hydrogen gas, they aren't water anymore. They're 2 separate gases with unique properties. So that's important. The atoms have to rearrange for that to be a chemical change. So precipitate is stuff that falls out of solution. And we'll do several precipitation labs over the course of the year. And it'll be really important when we're talking about ionic compounds, but this lab doesn't have that, okay? Gas bubbles, again, gas formation when it's a new substance like hydrogen and oxygen versus H2O, that's important. If just boiling or sublimation like carbon dioxide, dry ice, is solid when it's dry ice, but it quickly goes to CO2 gas when it's exposed to normal conditions. Color changing that isn't from dilution. Temperature change, this one's the tricky one. A lot of times temperatures go up, but it's still a physical change. I don't think we're going to be able to detect any kind of temperature change with the physical changes we're doing in this lab because our thermometers aren't that good. But we'll talk more about heat of solution later. Changing the pH, so you know about acids and bases a little bit. We're going to talk about those today too. And production of light. If you got fire or light, there's a chemical change going on. Okay. The changes that we're going to be looking at, it's really important to keep in mind that matter can't be destroyed or created by a chemical reaction. Whatever you end with, you had to start with, whether you realize it or not. The air in the room has oxygen and nitrogen in it, and they can become part of the stuff that you're forming. So, and that happens a lot. So it took a while for people to really get on board with this law. The other thing is, as you'll see today, when you make a gas, it's really hard to keep it in a container. So the baggies that I used earlier today were really good and stayed sealed. The ones that I used fifth period, not so good. It leaked a lot. So anyway, that's a problem. And then acids and bases. So acids have pHs below 7. Bases have pHs above 7. And they turn different colors with universal indicator. And I'm going to show you that and some litmus paper. You've probably seen litmus paper before. There's 3 objectives. You can read those on your own. I just want to remind you that all this material that we're dealing with is all stuff you probably have in your kitchen. I'm guessing you do. Salt and baking soda and vinegar, not like deadly chemicals. Okay. So just be careful. Don't throw it in your eyes, you know, be safe. There are pre-lab questions. Don't do them yet. This is where you're going to make some predictions. I'm going to show you a few things. I've already put water in because it's kind of, I can't talk about indicators without showing you water. So universal indicator is a green liquid. I'm going to show you in just a second. And sodium hydrogen carbonate is the official name of baking soda. Sodium chloride, of course, you know, is the official name of table salt. Acetic acid is the official name of vinegar. So we're going to do some physical changes and one chemical change. Okay. So the first thing I'm just going to show you is this part A. I'm going to show you what colors they turn, and then I'll explain what you're going to do in part B. So let me stop this part. Maybe. Oh, heck. Let me get this. This is universal indicator. It has a whole bunch of different pigments in it that change color based on whether something's acidic or basic. Alkaline or acidic is another, alkaline's another term for being basic. And this particular substance is green when it's neutral. So the green color, this is pure water, distilled water. The green color tells me the pH is 7. The other two substances I just want to show you. This is a bottle with hydrochloric acid in it, and hydrochloric acid is the acid in your stomach that helps you digest your food. Just pouring a few drops of this in here. And when you look at it, it looks like water. It doesn't look like anything. When it gets on a cut, it does look very different though. So if I put some universal indicator in that clear, colorless liquid, I have red. Okay, that tells me it's an acid. And then the other substance that I have is this sodium hydroxide. Again, it just looks like water in there. Actually pretty dilute, but sodium hydroxide is nasty stuff. It's the stuff that you use as drain cleaner, and also oven cleaners have it. It's called lye, L-Y-E, and it probably looks kind of black to you guys, but maybe you can tell it's actually kind of purple. And that is indicating that this is a very strong base, and a pH of 14. Okay. So again, on your table, or at the bottom of the first page, red for acid, green is neutral, and purple blue is for bases. And so you should have that information in your head. And what you're going to do for your predictions is you're going to predict what's going to happen. What do you think is going to happen when I put universal indicator on the salt, on the baking soda, and in the vinegar? But obviously really soft, but how much of the water? So another type of indicator you may be familiar with are litmus papers, and litmus paper has this paper that's been soaked in plant pigments for a bit, and it comes in, they call it red and blue. They don't look red and blue, they look pink and purple, but that's okay. That's my eyeballs, I guess, I don't know. If I put acid on the blue paper, it will turn it red or pink. And if I put acid, base on the pink paper, seems a little more obvious, it turns it blue. So litmus, every single plant pigment kind of changes color at a different pH. And so universal indicator has multiple things in it. Litmus is really close to breaking at 7. So it's, you can quickly decide if something's acidic or basic with litmus, which is why it's used, and it's relatively inexpensive. Some of you may have hydrangeas, big plants that have the big puffball kind of flowers. You can put acidic fertilizer on those and get them to turn pink. You can put basic fertilizer on them and get them to turn blue, depending on what color you like. So it doesn't harm the plant, which is kind of interesting. So, all right, so what are you doing? You're going to use your little cup. And I have a jug of water. You don't have to have a jug, just tap water is fine. You're going to take that and pour 50 milliliters or so into your cup. You're going to use your thermometer and get the temperature. You need to make sure that the bulb of the thermometer is below the liquid surface completely. You need to leave it in here for a couple of minutes. Obviously, water should be clear and colorless. So you just need to let it sit and equilibrate for 2 to 3 minutes. And again, these thermometers aren't the best, and they're a little bit hard to read. But you might notice as I change the angle, you can see the red line better at a certain angle, like right there. So just make sure that if you look straight on and you don't really see it, just kind of turn it at an angle. I'm reading My bad eyeballs. I need to go to the eye doctor. 18, it's between 18 and 19, so I'm going to call it 18.5 for my starting temperature water. And then what you're going to do, if you have a measuring teaspoon or a half teaspoon, use that. Otherwise, just use a regular spoon and don't put a lot. But you're going to add to some salt, about a half a teaspoon. This is kind of a big spoon, but and put it in there, okay? And then kind of stir it up. Notice what's happening. See what happens to the temperature. Does the temperature change when you put the salt in the water? Okay? And I'm not going to tell you what's happening in mine because I want you to do it yourself. But, so once you're done with that, and you've again got to give it a couple minutes. It doesn't happen instantly. These aren't digital. Once you're done with that, you're going to rinse everything off. And now do that whole process again. With water and baking soda, same process. Get the temperature to start, then add the baking soda, stir it up, get the final temperature. Vinegar, it doesn't have to be white vinegar. It can be balsamic vinegar. It can be what's the word for the apple cider vinegar. It doesn't matter. This is vinegar. Okay, so you're gonna put 50 milliliters of that in, and some salt. Okay, so those three: water and salt, water and baking soda, vinegar and salt. Those are all your should be physical changes. Let's see if a temperature change happens. The last one's a little trickier, and that's for the chemical change. And I see a couple comments. So I'm going to check what's going on here. Okay, beautiful. So the last one is use your 50 milliliter vessel to get the vinegar. It doesn't have to be exact, okay? I will measure and get masses on. Take your little sandwich bag. You can use quart bags. Quart bags would be easier if you have them. Don't worry if you don't. If you only have gallon bags, you can try that too. So you've got a bag. You're going to take, again, about a half a teaspoon of baking soda. I wouldn't go over that because put the baking soda in one corner. Oh, bad feature. Put the thermometer in the vinegar first and get that starting temperature. Give it a couple minutes. So I'm going to go fast. You need to go a little bit slower than this. The next part's kind of hard. You got to get this stuff into the baggie. And so, do this someplace where you can spill. I have Ziploc brand bags that I used this morning, and this would fit the thermometer and it would fit inside the cup. Do not fit in these Walmart brand ones. So what you're going to have to do is do a little finagling. Try not to tip it over. You're going to make it so that the thermometer, the beaker of vinegar, and the baking soda all live happily ever after. Yep, we started. Oh well, make sure the bag's zipped. I already lost a bunch, I'm sure. What you're going to want to do is get that thermometer bulb into the fizzy stuff and watch what happens to the temperature. So you should have a starting temperature before you tip it. So just be careful. Oh, you can see. Oh, this one's sealing better. The bag I used last period did not work. So it should be fun. It should be entertaining. Just make sure you rinse everything off when you're done. Set it aside to dry, and we'll talk about what your results are tomorrow. But it is. Okay. Questions? Seeing none, If you have questions and want to stay on, you can. Just, you're getting observations and temperature readings before and after. They are, I believe they are, hopefully. So if you don't have questions, we'll see you tomorrow. If you have questions, stick around. I'll try and answer them. And I'll do the meeting on. You can pop back in if you think of something later.
Bye. Thank you.
Bye. Have a wonderful day. Have a wonderful day. Thank you.
For the vinegar, do you just keep it in the beaker in the Ziploc and then combine it with the baking soda?
Yeah, you want to have the zipper zipped, not like I did. You want it all sealed before they come together if possible.
Okay, thank you.
Yeah. Colin and Michael, can I answer anything for you? Oh, I'm sorry. I'm going to stop the recording and I will post it as soon as possible. Hopefully you can hear it on YouTube.